Hello everyone, welcome to the classes. This is Priyanshu Agrawal and today we are solving December Cookoff Challenge 2021. So we have a question musical chairs. Our third problem is musical chairs. So now let's read the problem statement. There are n friends who decided to play the game of musical chair one day. Initially they decide a number k and with each passing round they move exactly k chairs. Hence in each round exactly k players are eliminated. The game stops when less than or exactly k players remain in the game. Now chef wants to figure out how many possible values of k there will be exactly one winner. Okay, so we can see the test cases. Here is input test cases. Okay, so now let's understand in the whiteboard here. So we can read out this problem statement and we know that there are n chairs and also they written that there are n friends also. Okay, so now they say that if they remove k chairs and that means that they remove k friends. Okay, so now what we had, they have said that how it is possible to be exactly one winner in the game. Okay, so exactly one winner means there should be only one chair left with us. That means one winner. Here is, suppose we take our test case. First test case is 2. Okay, so we have 2 chair, so we can remove one chair here and we'll left with one, and we have to be left with one, so only that possible combination will be one. So our answer will be one possible combination, and this is our input number. Okay, so our second test case will be suppose our second test case is 3. Suppose our number is 3, so it is possible that we take out 1, then also we'll get 1 we take out and it is left with 2, and then again we take out the 1 and we'll left will be 1, and we have to left with 1 chair. So this is correct, and suppose our another test case can be 2, because our another outcome can be 2, because we take out the 2 chairs from the 3, so left will be the 1 chair. So our possible combinations will be 2. Okay, so our next input is 4, and it is possible only for 1 to remove it and 3 to remove it. As we'll remove 3 chairs, then we'll left with 1 chair. So here also possible is 2 combinations. Let's take another test case. Suppose our number is 7. So for the 7, it is possible for 1 to take it out, and after that for another number can be, that can be, and the your can number will be 2, and your number will be the 3. Okay, and 6. So there are 4 possible combinations. As if we'll take out 2 2 2, so it will be 6, and then 1 little left, and 3 3, then again we'll take it out 3 2 times and we'll left with 1 chair, and 6 if we take it out, then we'll left with 1 chair. Again one more test case we say, suppose 8, so it will be 1 and 1 and 7. This will be the 2 test cases here. So we can see here we are getting factors of n minus 1 here. So this is the logic for here, that will be we are getting as factors of n minus 1 as our outcome. Okay, so now let's code this. So our input will be an n, so we'll take a variable int n, and we'll take input n, and we'll write for int I equals 0, I less than n, I plus plus. Okay, so if we'll write this code here, then we'll get an, okay, so first we'll do n minus minus also, that is n minus 1, and if we'll write here I equals to 0, I less than 1, then we'll get that error as time limit exceeded. So for that, to remove it, we have to write the square root of n, so that we should reduce the time complexity. This runs on O of log n, and you can read it out in the link in the description. There will be a Geeks for Geeks article. You can read this article. You can read out there. So I'll write it this, and we'll write, suppose if n percent I equals to 0, then if our n divided by I equals to I, then we have to simply do our, okay, we have not taken variable int count, taken variable as int count, and we'll initialize as 0. So we'll just simply do here count plus count. Okay, and else we will do here count plus 2. Okay, so this is our code, and we'll simply print our count. Okay, so let's take our input test case here. Okay, so I've done here a mistake, that is I equals to 1 and I greater than equals to sqr rtn. Here it will be, that is our output test case is coming as 1 to 2. Okay, and our test case output case is also 1 to 2. Now let's submit it. Okay, so we can see that our answer is correct here, is median minimization, and you can see in the click on the next video and you can see the solution of it and the explanation, complete explanation of it. Thank you.